Okay, it says you calculate the velocity of car A after the collision. So let's write down the data. Let's say we have the data here. So the data, let's say car A now. Is car A. So in car A, we are given a mass of 1.5 or 1.25 m. So let's say this is the mass of 1.25 m. Another thing, since we chose east as a positive, that means the vector that is going east is positive, then the vector that is going in the opposite direction should be negative. Now car A is moving or is traveling east at 32 meters per second. That means this should be the velocity, which is positive 32 meters per second. East is this one. Now car B, let's go to car B. So car B, we are given a mass of m kg, cos kg, and then we are given the velocity. This one, since car B is going west, that means the velocity should be negative 27 meters per second. So now after the collision, this one should be initial, this one should be final. After the collision, they said car B continue moving at what? Okay, it moves east at 5 meters per second. That means this one's initial, this one is final. It's going east, now it's positive at 5 meters per second. So now the question say we are looking for the velocity of car A after the collision. So since we're talking about the conservation of linear momentum, now the formula says the sum of momentum initially is equal to the sum of momentum final. So this means that the mass multiplied by the velocity initial of car A plus the mass multiplied by velocity initially for car B is equals to the mass multiplied by velocity final for car A plus the mass multiplied by velocity final for car B. Now we just take from the data now. Car A, initially the mass is to 1.25 m. The initial velocity is just positive 32. Now we move to car B. The mass is just m. What about the velocity? It's negative, since it's going west, 27 is equals to the mass of car A, 1.25 m. What about the velocity? We don't know the velocity. We're just looking for the velocity. What about the car B now? The car B is m for mass. What about for velocity? They said it moved east at 5 meters per second. So now let's do the math. So it's 32 here. We have 32 multiplied by 1.25 m. That will give us 40 m. Just 40 m plus. Okay, let me see. Minus So it's 27, negative 27 multiplied by m, so it's 27m is equals to, this, it should be 1,25 m multiplied by the velocity final of a plus 5 multiplied by m, which is 5m. So now 40 minus 27, that will give us 13. That will give us 13m equals to, okay, we have 1,25 m VFA plus 5m. So now let's group the like terms. We take those ones with m and put it on our right hand side, left hand side, I mean. So that will be 13m minus 5m is equals to 1,25m VFA. So 13 minus 5 should be 8m, so equal to 1,25m VA. So remember, we are looking for the velocity of car A, so we divide by 1,25m. We divide both sides, 1,25m. So this will cancel this. So VFA is equals to, that will give us 6,24 meters per second. But since this is the velocity, that means it has the direction. So since the velocity is positive, and from the beginning we chose east as positive, while now our final velocity is positive, that means car A is going where? It's going east. So this is the final velocity of car A after the collision. Now let's move to the following question. The following question says, now the impulse, calculate the impulse experienced by car B in terms of m. So we know that impulse, we have this formula, F net change in time is equal to change in momentum. So we know from this formula that this is our impulse. This is our impulse. But since we don't have time, or we're not given time, but we can be able to calculate the change in momentum. While from the formula it says impulse is equal to the change in momentum. So that means if we can get momentum, it means we have impulse. So let's calculate our change in momentum. So it should be question 4.2.2. Change in momentum, it means what? They're talking about car B. That means we have the mass of car B, change in velocity of car B. So what does that mean? Since we're talking about one object here, obviously it's going to have only one mass but two velocities. So we have the final velocity minus the initial velocity. So now what is m? M is just the mass of car B were given as m. F finally is the final velocity, that was 5, minus the initial velocity, the car, it was moving at 27 meters per second, but it was going west, and west, we chose west as negative, so that will be negative 27. So now m 5 plus 27, so negative multiplied by negative, it should be positive. So what is 5 plus 27? That will be 32 m, but the unit, it should be kg meters per second. So now what is the impulse? Therefore, impulse is equal to 32 m, since the question said in terms of m, so the impulse should be 32 m Newton seconds. Since, remember, this is F net, remember impulse is the product of F net and time, so F, we measure it with the Newton, while time, we measure it in second. So now the SI unit for impulse is in Newton seconds. I hope that will be simple.